In this video, we're going to be talking about how to use synthetic division to divide a polynomial by a binomial. It's important to note that this material is a little different than what's in your textbook because your textbook only shows you how to divide by a binomial with a lead coefficient of 1, and I'm going to show you how to divide synthetically by a binomial with any lead coefficient. So it'll look a little different than what's in your textbook, but there's a supplemental note sheet that you'll be receiving as well that has all this same information on it. So this video will serve as just a couple of examples of how to actually perform the synthetic division. So the first example that we're going to look at is example number 2 from your in-class worksheet yesterday, in which we took a minus 15 plus 6a and divided it by 2a minus 3. So we did this yesterday using long division, and to give a side-by-side comparison, we'll do it now using synthetic division. So first things first, we've got to do the setup. So the setup for synthetic division is kind of similar to the setup for long division. We want to start by putting both the numerator and denominator in descending order. So the denominator is 2a minus 3, and the numerator 6a squared plus 1a minus 15. Remember to put in any necessary zero coefficients so that both parts go in descending order from the largest exponent all the way down to a constant. So in this case, again, we don't need a zero coefficient because my exponents go from 2 to 1 to a to the 0 power already. Alright, so there's nothing missing from the coefficients in this example. So the next step in terms of setup for synthetic division, we need to take the numerator and divide by the lead coefficient of the denominator. So in this case, the lead coefficient of the denominator is 2. That means I'm going to divide each of these terms by 2. And I'm always going to leave the last term written as a fraction. So what I get as a result then are the numbers 3 for my first coefficient, 1/2 for my second, and again we're always going to leave the last term as a fraction because this will eventually become my remainder, which should be a fraction. Once I've divided everything in the numerator by the lead coefficient of the denominator, I no longer need the coefficients for the synthetic divisions. I no longer need the variables for synthetic division. So I'm going to take just the coefficients from the numerator, and I'm going to use them in my synthetic division. So I'm done with the setup of the numerator. The second part that I'm going to need in order to complete the synthetic division is a multiplier. And the way I find that multiplier is to find the 0 of the denominator. So I'm going to take my original denominator, 2a minus 3, and I'm going to make it equal to 0 so that I can find the value of a that makes that expression equal 0. So we'll add 3 and divide by 2 and find that the 0 is 3 over 2. So that number then becomes my multiplier. Alright, now I'm set up for the actual synthetic division. Once I've got everything set up, now I'm ready to perform the actual synthetic division. And we'll walk through these steps in sequential order. So to perform the synthetic division, there's a simple algorithm that involves multiplying and adding that you're going to use. Here's how it goes. You always start by bringing down the first coefficient. Don't do anything to it, just bring it down, and that's it. Then we're going to multiply. We're going to take our multiplier, 3 over 2, and we're going to multiply it by the numbers in this bottom row. So the first number there is 3, and the result is going to go just below the next number in our synthetic division. So 3 over 2 times 3 is equal to 9 over 2. And then we're going to add. 1 half plus 9 halves is 10 halves, or 5. Then we're just going to keep repeating that process until we've gone through all of the coefficients in synthetic division. So the next would be 3 over 2 times 5 is equal to 15 over 2. And then we're going to add. And again, the last term we're always going to leave as a fraction. So we end up with 0 over 2 for our last term. All right? And that is our synthetic division. So when you've completed the synthetic division, your answer will come out to be this bottom row, and it's going to come out in descending order. Right? So I'm going to work from right to left, so I'm going to write in my coefficients for my answer in ascending order, but when you read it, it'll come out to be descending order. This term is your remainder. Over the lead coefficient of your denominator. This is your constant, and this would be a to the first. If there were more terms, we would just add variables with an increasing exponent. Right? So for this particular question, our answer comes out to be 3a to the first plus 5 plus a remainder of 0 over 2a minus 3. Right? So the 2 is the lead coefficient for my denominator. The remainder is the numerator. Let's go ahead and take a look at another example of synthetic division, this time a little faster. We'll do one from your homework last night, just so you can compare answers side by side. You should also be able to use the synthetic division examples with the examples 3, 4, and 5 from the in-class worksheet yesterday. So the second example we're going to do is number 41 from your homework last night. It was 6x cubed plus 11x squared minus x plus 10 divided by 2x plus 3. So we'll walk through the setup a little faster for this one. Again, we're going to write both in descending order. And we've got to remember again to check to make sure that there are no missing coefficients. Alright, so the degree of my numerator goes from 3 to 2 to 1 to 0. So there are no missing coefficients there. I'm good to go. And similarly, the degree of my numerator goes from 1 to 0. So in descending order, no missing exponents. So no need to add in any zeros. Alright, then I'm going to divide by the lead coefficient of the numerator, of the denominator, which is 2. I'm going to divide everything in my numerator by 2. I end up with 3/11 over 2, negative 1 over 2. And the last, again, should always remain a fraction, even if it's simplifiable. And then we're going to find our multiplier, which is the 0 of the denominator so in this case it's negative 3 over 2. And now I'm ready for the synthetic division. Alright, so I'm going to go through and again just perform the synthetic division. So bring down the lead coefficient and multiply. Negative 3 over 2 times 3 is negative 9 over 2. And add, I'll get 2 over 2, which is 1. Then multiply again. Negative 3 over 2 times 1 is negative 3 over 2. And add, I'll get negative 4 over 2, which is negative 2. And then multiply again. Negative 3 over 2 times negative 2 is positive 6 over 2. And I'll add, and again, always leave the last as a fraction, since this will represent our remainder divided by the lead coefficient of our denominator. So I know then, for this question, the solution to 6x cubed plus 11x squared minus x plus 10 divided by 2x plus 3 should come from remainder constant x to the first, x to the second. So 3x to the second plus 1x to the first minus 2 plus 16 over, again, the 2 is the lead coefficient of my denominator, so 2x plus 3. Kind of a funny way to write the denominator. Alright, so that was my final answer.